Hello guys, welcome to the very first lecture of your backend development. Out of this lecture, we'll be looking at databases, okay? And databases is not exactly a difficult concept per se. Databases per se, they look something like these that you have in the images there. But throughout this lesson, we'll be really digging deep to find out what is exactly going on within those machines that you see within those images. So, a little bit about myself. I'm the chief instructor of the CWA, or Codewise Academy. I'm a certified EC Council instructor. I am a software engineer specializing in backend development, cybersecurity analyst, and digital forensics analyst, computer scientist, and a couple of other things to the credential. So, I'll be helping you throughout this entire course in your backend development entirely. Okay. So let's really talk about databases. What really is a database exactly? We keep on hearing things about databases, but what really is a database? So if we can roll things back a little bit without saying too many big words, well, a structured collection of data that is easy to access and easy to retrieve and manage in a specific manner, that's essentially a database. Now, this is not to say we're dealing with digital databases per se, we're just speaking general databases. So we're talking whether it is a file system that you use or if it is a clinic that's full of files, shelves full of client files and so on and so forth. That's a database, essentially. Okay. The benefits of databases are you're allowed to organize your data in a certain storage, and it is efficient for retrieval. I know the clinic example might seem like it's not really as efficient, but it is efficient to a certain degree, you know. One thing we can tell is that those shelves that have those files, they may be arranged within a specific order, and it be that they may be arranged in alphabetical order. It's a more efficient thing to do rather than arranging all those files in no particular order at all. So it is more efficient in that manner. Yes, you can share and collaborate. Now, this becomes subjective in the context of the databases that are hard copy. There is no idea of sharing there. You're like, yeah, but I can get the file from the nurse. No, there's a difference between giving and sharing. Sharing, I keep some of it and you take some of it, or essentially I keep a copy, you get a copy. That's the whole idea of sharing. So a proper and efficient database needs to have the whole context of sharing and collaboration. We should be able to work on the same file or the same data all together within the same time. There is the issue of data and integrity. When it comes to data and integrity, yes, dealing with things in hard copy, it keeps integrity. It may be a little more secure than the electronic. Well, that's probably because the person who set up the database didn't have security in mind. However, when you are creating a database, you have to have that security approach in mind. Okay, so now there's this thing called relational databases, and this is essentially what we're working with. When we're talking now about our electronic databases, the one that you are going to be building and working with throughout your web development course, we'll be working with, well, relational database. And the whole idea of a relational database is where we have information within the database that is related to one another. Or in layman's terms, we have these informations that are stored in tables. So they are essentially in tables, and entities from one table to another table are able to interact with one another. So, what in the world of Mars am I really saying? Okay, let's get an instance. So you can have one table per se and another table. This is the whole idea of relational database. You have these values that are within the table. They are able to relate to the values in other tables. For example, if this was a school's database, you can have a database full of students and you can have one that is full of teachers. Now, there is a link between the two. Every student can be allocated to a teacher. There's a relationship between the two. That makes sense. Okay. Okay, fine. Now there's this known as entities and attributes. Now we're digging deep into relational database. There are entities and attributes. So an entity is essentially an entry per se. Okay, it's basically properties of an or of a real world object per se, like a person that can have certain entities like their first name and blood type and so on and so forth. Okay, and each of these will have attributes, which are just little descriptions per se. Now, this would make a little more sense when we start building our database management system, or we actually start sketching a graph of how our database would look like. Then these will make a little bit more sense, but they are as crucial when it comes to developing your database. Okay, okay, but then what is inside a database? That question still needs to be answered. So inside those big machines that you saw, these computers, and inside those computers, there's a service that's running. And this service consists of these entities that you see here: tables, schematics, queries, and views. Now, as we mentioned, all information is arranged in tables. Okay. So inside your database, it's full of these tables. Okay. There is a schematic, which is sort of like a blueprint that shows the structure of essentially all your tables. Okay. That's basically what a schematic. And you'll see this when we're now building a database as well. Because when you're actually building the database, you are building using the schematic. And then there's queries. The whole idea of querying is manipulating, analyzing, fetching the data, and so on and so forth. Okay. And do not worry about the database views as of yet, but it will make more sense as we proceed with this lesson. So when I'm now thinking of building a database, yes, I decide I would like a database, fine, and I decided, yes, I'll create a relational database. So inside this machine of mine, I need to install a special software that will allow it to become a database, that will allow it to serve the service of being a database. So this type of software that is very special that I really need is the database management system. So a database management system is then responsible for all that information exchange across the entire database. Information that's fetched, put into the database and everything. It's responsible for all this information that is going on and off and on and off and on and off. Whether it's being manipulated, deleted, updated, or whatever, it is responsible for this job. Okay. And another thing, it is responsible for security to a certain degree, of course. You cannot just install a database management system and believe that it's secure. You have the largest part to play when you're setting up that database management system. So there's different kinds of database management system softwares out there. The most common are the ones that you see right now on the screen there. We've got MySQL, which is very, very common. It's MySQL is more used for much larger projects per se. It's the most commonly used. It's open source. It's free, very easy. And then we have MariaDB. We'll also be seeing this one as we proceed as well. It's very much similar, if I can say, to MySQL. Not much of a big difference there. Okay, then there's PostgreSQL. This one I believe is more secure in my own point of view. But nonetheless. Then we have MongoDB and SQLite. You will be working with pretty much most of these database management systems. Maybe not PostgreSQL in much detail, but you will be working with most of these. SQLite. Looking at SQLite, this is the one that we're actually going to be working with today. So in this lesson, we'll be dealing with SQLite. Now, let's talk about SQLite a little bit. Now, SQLite is very lightweight, as the name says. It's a light relational database. It's embedded, okay? So the whole concept is, other than having the entire PC serve as a database, we can have a single file that becomes a database. That's the whole concept of SQLite. One file will become a database. Just like how we had Microsoft Access was able to create a database, you're able to just serve that file as a database. Whether you want to use it in your website or whatever, it can serve as a database. Now, you would want to use this SQLite for small to medium-sized applications. You cannot go for large databases like the IRS or some sort of government entity running on SQLite. That would not be the best idea. Another issue with SQLite is you have to lock in the file that you're working with. Okay, as I've mentioned, it's flat file. You're working with a file. So if this was my database file, and then this is me, and this is another person. If I am using the database, I'm reading information and maybe I'm inputting information, this person here cannot insert any data into that database. They cannot do that up until I am done with that database. Then and only then are they allowed to use that database. Probably wondering, okay, what's the difference between it and the other relational database management systems? Well, it's lightweight, it's embedded, and it's a single user focus. Only one user can connect to it, manipulate the data, and done before any other can do so. Whereas with MySQL, it has multiple users that can actually connect to that service, insert some data, remove the data, fetch some data, and so on and so forth, all at the same time. By coincidence, it can happen. And it's server based. So it's not very much one that just runs on any PC. You need to have that service installed. Okay, now let's talk about that database modeling. Now I've decided which database management system I would like to use. Let's just suppose and propose I would like to use SQLite. Now I need to start database modeling. I need to start defining the structure of my database. Okay, so when we're doing this, you're sort of deciding what kind of tables would I need to exist for this database. Okay. Now let's suppose and propose that there's a movie, there's a cinema of some sort. So a certain cinema has movies that they are allowing people to buy tickets to go and attend to, which is fair enough, right? Yeah. So let's suppose we would like to design a database for that system. So where you would want to start off first is your database modeling first. You would want to start deciding which tables must exist. You may think, okay, maybe I might need a table for the list of movies, and maybe a table for the list of the classifications of movies to say, is this action, horror, or whatever. And maybe you might, I don't know, have a list of people who might want to buy tickets from there. And maybe another table of purchases, with purchase histories for those who have bought tickets before. Maybe you can have it in that manner. Okay. And this database modeling and generating of ER diagrams is very important and very crucial. Okay. We use this to plan and document the entire structure, the entire outline of how this is supposed to be. How is information going to flow from one entity to another? Okay, like so. How do they relate to one another? Hence, it is called a relational database. Something like this. That would make it more sense. It improves communication and understanding. That's for the case where you are working in a team to develop a certain application of some sort. Then you, who's building the database, you should be able to give your entity relations diagrams and the entire sketch and schematic to someone else who might need to use it. Perhaps maybe it's someone who's working from the front end and they want to create a form that's supposed to push data into your database. Then that becomes very, very, very important. You should be able to give them that entity relations diagram. So it's very much the first step, the first thing you'd want to develop while you are building your application. Okay. And an ER diagram looks something like this, which kind of, if you can see, it outlines each and everything. This is the same thing, it goes there. Those are what we call foreign keys. So when we're talking about relationships, we have what are known as foreign keys, and we have what are known as primary keys. In this context, primary keys are actually in bold and in white there, like here, like there. There you've got a primary key, there you've got a primary key. It's actually written next to it, PK for primary key. So a primary key is basically a column inside your table that is not allowed to have a duplicate. Okay, you cannot have a duplicate. Okay, for example, blood type ID, we're not allowed to have duplicates for that, and so on and so forth. Okay, and then a foreign key is basically values that come from another table. If you look at the table donations here, now the table donations has this donor ID attribute there. However, the donor attribute ID is also a value that's used inside this table, donation ID. They must match. If I have a certain donation ID that has been inserted here and it does not exist here, then it's going to have a problem. Not going to permit it to do that. So this is to limit and allow your database to have that integrity so it doesn't get messed up. I mean, imagine if SARS was hiring people from all over the country, but then all of a sudden they hire a person that does not exist within the home office. They don't exist as a citizen. Then that would be an issue. That's a very great example that you can get when it comes to foreign keys. Okay. Anywho, that was a lot of talking. Yes, I think it's time we do some building. All right. So when it comes to building, building is very, very complex and a little bit twisted per se. So let me just go back down here. All right. So when it comes to building, let me just get rid of this. Okay. Not save that. Okay. Now we're going to be building our database. Okay. Now, of course, you should have a sketch of the database that you would like to build first before you start building it. All the entities that are supposed to be within the database and so on and so forth. You need that. Okay. So what we're going to be using to build our database is something called DB4S. Okay. Of course, DB4S is not the full name. The actual name in this case is your SQLite database browser, like so. Now we will be using dbeaver probably in other sessions to come, but now we're just sort of introducing the concept of SQL. Okay. Now I'm gonna allow my SQLite DB there. It's now open. So here, now I am creating a database. So there's these statements that you have to know. There's no any other way around it. You have to know them. So let me do this. Okay. Just gonna have a little text file right here. Okay. So there's these statements that you need to know. You need to know what a create statement is, what an insert statement is, what a delete statement is. You also need to know, well, there's a couple of create, insert, delete, drop, and there is a couple of others, but these are quite some of the most crucial. Okay, now create is commonly used when you are creating something. In this context, when I'm creating, well, the name says it, to create. And insert is to like insert some data into a table. Delete is to delete an entry in a table, and drop is to drop an entire table. Okay. So here we go. Once you're in your SQLite, you're gonna right click, or rather left click on new databases. Okay, once you're there, you can navigate to a place where you would like to save your single file, that file that you would like to create. Okay, we can go there. So in this case, we said movies, right? Yes, the movie, or let's call it the movie cinema. Okay, we're creating a cinema after all. All right. So now let's think about this. Now, once it's like this, it's ready for you to create your first table. So if we put it down this way, okay, we put it down this way. We are going to have a database with all these entities and so on and so forth. But there's a specific manner we have to put it in. We have to plan this thing properly. So I'm going to get Zerno, which is a very cool tool that I use to just draw things. You can use a pen and paper. Of course, you can use your phone if you're able to draw on your phone and so on. As long as you're able to document and share that drawing with other people, there shouldn't be a problem with that. So here, now I'm designing the database, and I've decided, okay, we're going to have a table of movies. Okay, we're going to have a table with the movies. We're going to write it in full. We're going to have a table of movies, and maybe inside the movies, we're going to need some entities. We're going to need an ID, some key, some primary key. So I'm going to put like a little star next to it just to show that it's a primary key. Now this ID, I will basically use this as a way of identifying a certain movie here. We do not necessarily identify them by name because we can actually have movies that have the same name. So I'd rather want to use this ID, which is supposed to be unique. Hence, we make it a primary key. So we're going to be using that as our identification. So we'll just call it ID. And then we'll suppose and propose that every movie must have a name, right? Every movie must have a name. And then we'll also suppose and propose that there's a year that it was released as well. Notice how I'm not making the name and the year a primary key, because you can have movies that have the same name. Even the year, you can have multiple movies that are released within the same year. Okay, fair enough. Now let's just suppose and propose as well that we have another table of, well, let's say people. So here I'm talking in the context of people who are coming to, well, buy the movie, isn't it? Or buy a ticket to that movie. So each person must have an ID. Again, we need to be able to identify people. And this, we can say, well, this is a primary key, isn't it? Okay. So every person, people shouldn't have the same ID. And whatever entity you would like for them, let's suppose we'll have their name. I'm not going to write that in full. And what can we say as well? Maybe we would like to store their email addresses as well. Maybe even their telephone numbers if we'd like. And let's just say that's enough for them. Okay, suppose we have another table now. And let's just say maybe this is a table of the purchases. The whole idea of buying. Okay, so all the purchases that are done here, we'll have them there. So each and everything should have a purchase ID. Okay, and then obviously whatever you're buying, we actually need the movie ID. Which movie did you buy? And if you think about this, you cannot buy a movie that they do not have, isn't it? Which is why we need this to be a foreign key. So we need this to actually point there. Okay, like that. So we will also then have a person ID. So I'll just call this PID. So this will actually cross-reference who performed that purchase. Okay. This seems like a rather simple database, yes. Okay. Nonetheless, now let's look at the relationships between each of those. So the movie to the purchase, right there. The movie to the purchase now. Let's think about this. Are you able to have a one-to-one or a many-to-one or many-to-many or zero to none and so on and so forth? So what I mean by this is, for a purchase, are you able to buy more than one movie ticket? Yes, you are able to do that. Okay, so you're able to buy one movie can be mapped to many purchases. So many is actually signified by two lines like that, and one is signified by that one. Okay, if it was in the context of none, as in no movie can be mapped to one, then it will be like that, which is a none to one. Okay, if it was the context of mapping a two or a many to many, as in many movies tickets can be bought by many people, which actually does make sense if you put it down this way. Many people can buy the same movie tickets, so it's more of a many to many, and even one purchase can have more than one ticket, so that's fair enough. Can you have one person make more than one purchase? Yes. So this would in fact be many to one. Should it be many to one? I don't really think so. I think this should be a many to many as well. Because if we think about it, a person can actually make more than one purchase separately. Maybe they got to the door and they thought, no, I would like to buy a movie ticket to go and watch Die Hard. And I forgot to buy Die Hard. Maybe I bought Happy Feet or something like that. Make sense? Fair enough. Now let's build this database. So we have to build the database in order of the information that flows. Okay. So what I mean is this. When I'm building my database tables, I cannot build this database table first. Otherwise, it does not know where the movie ID is gonna come from, because by the time the movie table does not exist, because you decided to start by creating this table, and even the person ID does not exist because you decided to make the purchase first. So it would be wise that I create this table first, and then I would create that one, and then maybe end with that one. Okay, because that one actually receives all those foreign keys. So let's create the movie database. Now we said you do this using the create statement. That's a way of doing it, yeah? So if you go to your database system there, we're gonna do this the more awkward manner. So let's just cancel this and do it the more difficult way. Yeah. So you're going to have to type in a command that creates that table, which is fairly easy. You're gonna type in the keyword create and what it is you're creating. In this case is table. And then you're gonna give the name of the table that you are creating. And the name of the table that I'm creating here is safe to say that it's movies. Okay. So the name of the table in this case is movies. And then you're going to open a bracket. And inside this bracket, you're going to give the schematic all the attributes that exist inside the table. Needless to say, ID, name, and year. Those would be the attributes you put there. So the first one is ID. That's the first one. And then you're going to hit a space. And then you need to explain what is the data type. What is the data type that ID has? Is it an integer? Is it a text? Is it numerical? Is it a real decimal? Or what is it? Well, ID, let's make this a more integer based. Okay, so we'll make that an integer. And then we hit the comma. We're actually done with that part. Okay, done with ID. And then name, we have to specify that one. Now it's name. Notice that I'm putting them in quotations, yes? Name, and name is more text. We can't have a name that's integers, comma, and year. So that's that part. And the year, well, we can have year also be an integer in it. I don't really think we have a year that starts with a 0 per se. Okay, we can close that bracket. For the sake of neatness, we'll have a space there. Now, because I'm done with this statement, each and every SQL statement that you do must end with a semicolon, no matter what. Once we're done with that, and you want to execute it, you'll hit play, like that. Now, it will give you an output and say, execution finished without any errors. If you had any errors, then you might need to go in and check and fix that error. Now it's done. If we go to browse data, you'll find that the table movies exists now, and it has ID, name, and year. Let's create the other table. So I'm going to highlight this and remove that. Okay. So now I would like to create the other table. So I'm not going to create the purchases table because it has a foreign key for person ID and I haven't created the people's table yet. So I have to create the people's table first. So create table, and the name of the table in this context is people. Like so. People. Oops, I don't need bracket. I don't need quotations around that. It's just people. Then there we go. Then we need to explain the entities. So we're going to have ID. We're gonna have ID, and ID should be an integer in it. That's just an integer, comma. And the next one is N, which should be name as mentioned, or quote unquote name. And name should be type text, right? Followed by E, which should be the email. So we'll say that's email. And the email I believe is fair enough as text. Okay, followed by T, and T should be your telephone number. So we'll just say that's telephone number. Can we have it as numerical or shall we have it as text? Numerical and integer will have a problem because you're not allowed to have an entry that starts with a 0. It will actually remove the 0 from your entry. So we actually want this to be a text. So that's for cases for numbers. Normal people's numbers would normally start with a 0. But if you have that data type of integer or numerical or real, it will remove any 0 that begins first. And we don't really want that. Okay, hence we want it to be text. Close that off. Semicolon at the end. You're probably used to the rules by now. And then we execute that as well. Executed successfully. Fine. If we go there, you'll see the people's table has been created. If you go to database structure, you'll find the very same thing. Now, yes, this is a cool way of creating tables. It's not the best way to create tables. So what I'm going to do is this. I'm just going to delete them. And delete them and so on. And start afresh with a more better way and a more friendly way of doing it. So if I go to create table there, you'll get that window that we had before. Now we're going to recreate it properly. So we have the movies table. So that's movies. Okay, and now we're just filling in the fields. So inside the movies table, I shall have ID. So I'm just gonna go there and say ID. Done. ID should be an integer. Yes. And then there's this thing that says NN. And NN stands for not now. Not now means it's not allowed to be empty. Everything must have an ID. And I really want this. Everything must have an ID. Okay. And there is the PK for the primary key. Yes, I want a primary key. I'm not permitted to have duplicates. And then AI stands for auto increment. And the whole idea of auto increment is that we will let the database management system allocate an ID for us. I don't have to manually go there and give it 1, 2, 3, 4. It will take care of that for me. And I think this is a special thing to have for this database. I'll have the auto increment for that. Then the last one, which is the U, is for unique, which does not allow duplicates. Now here in this case, we don't need that U because it's already a primary key, and primary keys on their own, they don't really allow duplicates. So we should be fair enough with that. Okay, then I'm going to create the other field. So that's name. And name, or name can be integer, name should be text. And name, I think, should be not now. Every movie must have a name for obvious reasons. I can't have this as a primary key, and I can't have this as auto increment. It's not an integer, so auto increment can't work. Primary key, well, we can have movies that have the same name, so both primary key and unique do not work in this context. And then we have year. So in this case, our year is fine as an integer. Every movie must have a year in which it was released. That's fair enough. Once I'm done with this, I'm gonna hit OK. Done. There's the movies table. I'm gonna create another table, which in this context was the people's table. And every person must have ID, not now, primary key, and auto increment that. Okay, and every person must have a name. This is not an integer, this is text. We can't let this be empty. And we said they'll also have an email address. Yeah, an email address is fair enough. And for that email address, it will also be text, and we'll leave that at not now as well. Okay, then we'll need the telephone number. So let's tell. So the telephone number, we said it's best as text. Then we'll also leave that at not now. Fair enough, that's that table. Then there's this a very special table now. The issue with this table is now the issue of foreign key. So here, let's create that table. The table is called purchases. Fair enough. And we said every purchase must have an ID to identify that transaction. So ID, we'll call it ID. And yes, not now, PK, and we'll make this auto increment as well. And then there's MID, in this case movie ID, isn't it? Which must cross-reference from the movies table, getting the ID from there. So this is the movie ID that is being bought. This can be empty, otherwise why are you transacting if you're not buying a movie? Then the last thing we'll have is the person ID, which should actually come from the people's table, isn't it? So there, that is also going to be left on, not now. But now we need to do this foreign key now, that line there. So starting off with the movie ID, the movie ID needs to come from the movie table. So when you scroll the side, you'll find the column of foreign key. That's where we'll be dealing with things. Let's start with the movie ID. We agree that the movie ID is supposed to come from the movie table under the ID key. So the movie ID, let's go there. If you double click there, you will get like these columns there. So under the first column, you're gonna select the table where it's supposed to come from. The movie ID must come from the movies table, and it must be the ID of that. And then I'm gonna go in there and hit enter. Voila, I've created myself a foreign key. Same thing with the bottom one too. The person ID must come from the people's table ID. So I'm just gonna double click inside. This must come from people, and it's actually the ID. Go in there and hit enter. And voila, I have successfully created that table. And then I can hit OK. So it makes those commitments, and beautiful. That table has been created. Okay, so done. We have our database perfectly so. Okay, out of just using our schematic in it. Okay, now we need to insert some data inside this table. Remove this. Let's look at it here. We have the movies, purchases, and so on and so forth. Do not worry about SQLite sequence. This is something else. Okay, it's actually there by default somehow. So we have the purchases table, it's there, the people ID is there, and the movies ID is there. Now let's insert some stuff into the database. To insert some stuff into the database, we can jump and start inserting things into purchases. Otherwise, what do we put on the movie ID and the purple ID? Because by that time we haven't inserted anything into those tables. So we have to follow the correct sequence. Meaning that I actually have to start inserting inside the table movies. Okay, so I'm gonna go to the movies table, is that one, and I'm going to insert my movie in there. So I'm going to show you the more complicated way of creating a movie and inserting it into that table. So to do this, you're looking at the insert statement. You looked at it, we did the create, now we're looking at the insert statement. So the insert, you'd say insert into, and then the name of the table you would like to insert into. In this case, the name of the table is movies. And then inside these brackets, you're going to put the entities or the attributes you would like to insert into. If you look at the table of movies, we've got ID, name, and year. I'm not going to insert anything for ID for obvious reasons, because remember we made ID to be auto increment. So I'm not necessarily allowed to put anything in place of ID. But I'll be inserting the name and the year. So for that part, I'll say I would like to insert the name and the year in that particular order. Now, obviously, I'm not done. I actually need to specify the values that I would like to put into this database. So I have to then say values. Okay, I need to specify those values that I need to put into that database. Okay, so to do this, I'm gonna say values, and then I'm going to specify the values that I would like to put into that into those spaces, and I have to put them in that order. Okay, so let's do that now. All right, so values, and then you'd have your brackets. Okay, so in this order, I would have the movie name. Let's say, I don't know what kind of movie I can have. Fast and Furious. Say Fast and Furious 3, for instance. Maybe that's out. We close this comma, and then I need to specify the year now. Now I don't need to put this in brackets because this is actually an integer. Let's say this came out in 2019. It may not have come out in 2019, but that's fine. Now take note of the order. Fast and Furious is first inside this order because name was first inside that order. Okay, if I said year and then name, then I'd have to put the year and then the name in that particular order. Okay, semicolon at the end. You hit play. Booyah. Execution finished without any errors. If we go to our database of movies, you'll find Fast and Furious is there. Let's just enlarge this a little bit. There's Fast and Furious 3, 2019. Perfect. Now let's suppose I had another movie that I would like to insert into this database table as well. Okay. Let's think. Which other movie can I add to this? All of a sudden I don't know any movies for some other reason. But okay, fair enough. Um let's think. I'm not too good with with movies. Okay, let's insert another table, another entry, insert into the table. The name of the table I'm inserting into is movies, and I wanna insert the name followed by the year, like so, and the values are like so. Let me think, which other movie can I add to this? Maybe the movie Hobbs and Shaw, yeah? Hobbs and Shaw. Okay. Let's say Hobbs and Shaw came out in 2021, for instance. That may not be the year, but okay. Execute that perfectly. It executed without any errors. Hobbs and Shaw actually appears there. Okay, fair enough. I can keep on inserting like that using this. I feel that is more okay. It's rather less convenient per se. So the best thing to do is to rather insert it from here as if we're using Excel. So I would go and click that. Then I would click the part where I would like to insert whatever I would like to insert. Okay, the movie that I would like to insert into this table, let's think about it. What movie would I like to insert into this table? Let's say Wrong Turn. Okay, yeah, let's say Wrong Turn 5. Wrong Turn 5 is kind of like an old movie per se. Oh, if it doesn't do that, you can edit it in there, by the way. Let's say Wrong Turn 5 is more of a 2016 type of movie. You can click on apply, it'll delete it there. Now we can keep inserting them like so. So now we just inserted a movie inside this part. Now we can actually create me, the person who would like to perform the purchase. I cannot get to the purchase database yet. Keep that in mind. So now I can go to the people, and then I can create myself in the database. I'll go there and click to create an entry. Then here, what's my name? Okay, my name is Nache. Enter. What's my email address? Okay, well, my email address is tanashe at codewiseacademy.pro. Okay, beautiful, fair enough. What are my phone numbers? 0123456789. Inserted. Perfect, now I actually exist inside that database. Seems fair enough, right? Of course, you could have inserted this from here using that insert statement. You could have done that as well. Okay, now that I have them in that particular order, now I'm able to make a purchase because I'm buying a movie that exists and the person who exists and is actually known is making the purchase. Now, when I get to this purchases, what I enter here must match. Movie ID, for example, the movie ID must be matching with a movie ID that actually exists. Hence, I'm looking at these IDs. That movie must exist. Otherwise, I cannot insert it there. Okay, it will actually spit in my face. We don't want that. Okay, if I go to purchases, let's just suppose I'm a stubborn person. You can actually see that it opened a little different. Suppose I go in there and insert a movie ID of maybe 10 and a person ID of maybe 20. Now, these people don't really exist, do they? And I try to save this, it will scream at me because that's a constraint issue. That movie does not exist. We don't know what movie you're talking about. So I need a movie ID that actually exists. Now, I'm a fan of horror movies, so let's just say I would like to buy Wrong Turn, which is a movie ID of 3. And my person ID, in this context, my person ID, my person ID is 1. Okay, so under purchases, let's have me make a purchase. So we said, let's just double check the movie IDs to make sure that I'm right. I'm buying my movie, Wrong Turn 3, right? So Wrong Turn 3, Wrong Turn 5 is actually ID number 3. So there, I'll insert. So the movie ID is 3 for Wrong Turn, person ID is 1 for me. And then booyah. I just got myself a ticket and it has been recorded. Seems fair enough, isn't it? Then the last piece to add to our whole arsenal now is that I now have to have the ability to fetch information from my database. This is now this part known as the select statement. I didn't write. Figured I forgot something. The select statement. Now for the select statement, the select statement is, well, as it says. Select, we use this to fetch some information. Let's start with something simple. Select everything from movies. Okay, semicolon. If I execute this, it will give me literally everything inside the table movies. That seems fine, right? Yeah. I can specify if I don't want everything. What if I just want the name? Well, I can say select name from movies. It will give me only the names from the movies. Okay. And of course, it doesn't have to be movies. It can even be person. Or there's no table called persons. It's actually people. So I'm only going to get the name of the people, basically. Okay. So let's just say we're sticking to movies in this context. And yes, we did see what the movies once gives us. It gives us everything there. We can be a little specific. If I don't want all of them, what if I want a movie that was released in 2019? So I can say movies where the year, or rather, where the year is equal to 2019. Okay, if you look at the movies table, so we can see that there's a movie that was released in 2019, that being Fast and Furious 3. So if we go there, we execute this one, we should get the name of the table or the name of a movie that was released in Fast and Furious 3. The same thing would happen if you didn't want just the name. Maybe you wanted everything about the movies that were released in 2019. You would get everything that has to do with the movies released in 2019. That is like the mere basics of insert statements in those SQLs. Okay. Now, that is pretty fair, pretty simple. So that is all you need to know for now. So, a quick recap. You need to be able to draft your own entity relations diagram. So I should be able to explain to you a certain table or a certain database that you're supposed to create. You should be able to sketch a table. After sketching a table, you need to create a schematic. Okay. So your schematic, you should be able to generate the schematic. I'm going to show you how a schematic looks like now. So now I'm going to just do Control S to save. We can click Write Changes for that context. Close this off. Let's save that. I don't know where would I like to save this. Okay, we're in web dev. Let me save. Okay, I want to save the project Saving that is way too much, far too much work. So if I go in here in my documents, I saved it in my documents under web dev. I should be able to find the movie's cinema. Yeah, I can reopen it with the SQLite browser again. There it is. Okay. You'll see, starting from upcoming lessons, we'll do things in a more complicated manner using a terminal. Terminal makes things a whole lot more fun. You'll find something called SQLite 3. SQLite 3 movies underscore cinema. Okay, if you do that, I've just opened this file just now. And if you look at it, I can say give me the schema, dot schema by notation. And I hit enter, I should get something. Okay. Now, of course, it will not work here because for some other reason it did not find that file that I'm trying to work with. So let me just close this and redo that again and sort of like maybe rename this file because some other reason it cannot find that file that I'm working with. Let's call this .db. It's supposed to have .db in the end. Okay, let me open my terminal here once again just to show you how the schematic looks like. So if I say ls, I should be able to find cinema.db right there. And when I use SQLite 3 movie underscore cinema.db. Beautiful. If I say .schema, I should be able to get all these commands. That is actually how the schematic looks like. The command, the create statement that was used to build those tables. That's how an SQL schematic looks like. Then you should be able to identify these relative to your entity relations diagram. Once you're able to make the link, build your database, create your links such as your foreign keys, primary keys, uniques, auto incrementations, and so on and so forth. And voila, you have yourself a database. Now, I hope that adds some value to that lesson. Might have been a mouthful. Now, of course, do not worry about the terminal in much detail. Okay, we will look at that one in upcoming lessons. Now, give it a try, and I'll see you guys within the next lessons.